So yeah, welcome to all of you for being here tonight. JavaScript, the hard parts, callbacks, and higher order functions. Before we do that, I believe some of you have already done this in other hard parts, but let's just take like a few introductions from some of you, just so we can know. If you can just tell me your name, where you are tuning in from, and maybe a good resource that you want to share with other people here tonight. So let's start with Mike from the West Coast. I've already completed half of your introduction.
Hello. I just program. I quit finance and
Oh,
I'm trying to become a developer. Thanks.
cool. Yeah. Do you have a resource that has been helpful in kind of like in your
Yeah, Dean. He's really good.
Dean? Is Dean
Yeah,
here?
the one in the chat.
Ah,
Yeah,
got it.
he's been
Mr.
very,
Dean.
very helpful.
Okay. I wonder why he's not sharing his face with us, but all right, good to know. Dean.
He's a coward.
All right. What about Hannah from Los Angeles?
Hi folks. So yeah, my name's Hannah and I'm from Los Angeles. And a resource,
Yes.
well, I have done, or I'm like working through some of the Colt Steel classes on Udemy, and I find them pretty helpful.
Yeah, absolutely. Yeah.
Thanks.
Cold Steel. Yeah, Udemy. Perfect resource. What about Allie from Boston?
Hi, I'm Allie from Boston. Um, I am in CS Prep now, so that's definitely a great resource. And I just made a CoderByte account, just another place to get practice problems to work through. And so far, I like the format of that one because sometimes I don't love the format of some of them. So I like that so far.
Awesome. CoderByte. Yes. Okay. Let's go for Kyla.
Hi, I'm also taking CS Prep right now with Allie, David, and Mike.
Cool. Yeah.
But I also love Edibit, which was introduced to us by our teacher Allison.
Yeah. Awesome. Yeah, Edibit. You just got you have these like challenges that you work through, right? Like different categories, different beginner, advanced, intermediate. Yeah, totally helpful. It's fun. So Edibit for all of you. Let's do one last one. James, what about you?
Yep. Hi, I'm James in central Pennsylvania.
Okay.
CSX has been super useful. Also, the Eloquent JavaScript book and the exercises there I found really useful.
Yes, Eloquent JavaScript. Very, very good recommendation right there. All right. So now that I kind of have a feel of like who's done what, where people are tuning in from, this is great. Now let us get started. So, who's gone to the callbacks this same lecture before? Anybody else? Everybody attending this? Mary, perfect. From Bangkok, that's so exciting. Okay, Ronald and Miko, perfect. All right, so a few of you, some of you haven't, which is great because this is what we are going to be learning tonight. So, callbacks and higher order functions. These, some would say, are kind of one of the most misunderstood concepts in JavaScript. People are like, callbacks, ooh, that sounds confusing. Higher order functions, I don't know, sounds kind of intimidating. I don't really know what those are. Sounds complex, right? But here's the thing, it's really not as complex as you might think. So tonight we're going to kind of like dive deep and break down these topics so that you'll understand that they're actually simpler than what they sound like, right? Sorry, I just got a notification. Give me 1 second. Perfect. All right. So I think I have an idea of who has been working through CSX, but how many of you are working on this section in particular, the callbacks and higher order function section, or have done it? Yes. Okay, perfect. All right, a few. Okay, so awesome, right? So some of these pro level functions should look familiar, right? Map, filter, reduce. In CSX, right, in that specific section, the first exercise in that section, you're going to actually have to kind of recreate what happens with these methods under the hood to truly understand how to implement them in future later challenges, which I do encourage you to do, right? It's all about iteration. Once you get comfortable working with a for loop, manipulating your array, try to see if you can start refactoring your code, and if you can implement map, if you can implement filter, if you can implement reduce, right? Now, these are, again, array methods. These are functions that are built into JavaScript that we can apply to our arrays. What is an array? Irene, do you have an idea of what an array is?
Yeah, array is the collection of basically any types. It could be like strings, could be numbers, could be
Yes.
other arrays. Yeah, could be objects. Yeah.
What? Perfect. Yeah, perfect explanation. What is the data type of an array?
Well, it can contain any data types, but it's well, the array data type is the non-primitive ones.
Yeah, so it's a composite data type,
Composite
right?
data type, yeah, and it's mutable.
Yes, it is a composite data type. Thank you so much, Irene. And as Irene mentioned, it can hold other data types. It can hold things like strings. It can hold things like primitive and non-primitive data types. It's basically an object, right? And it's notated with square brackets. We're going to see an array in our code, right? So array is an object notated with square brackets and can hold one or more values of different data types at a time. Now, map, filter, and reduce, besides being array methods, are also higher order functions. If you don't know what a higher order function means yet, it's okay. That's why we're here, to solve that mystery and kind of clarify that concept, right? What I will tell you right off the bat is that implementing higher order functions, right, using callbacks, which we are also going to discuss, makes our code more declarative and readable. So that just means that another software engineer can take a look at your code, and by looking at the higher order function of choice that you are implementing, they understand exactly what you are trying to accomplish just by reading it, just by looking at it. Now, why is this important? Why is it important that another engineer comprehends the code that you write? Well, like I mentioned earlier, right, in this industry, you're most likely going to be working or building really robust, complex applications for larger companies. Hopefully for companies like that have large resources like Google, like Facebook, like Netflix, right? Fan companies, but also startups, even like creative smaller firms, right? You still are going to work in teams. So, of course, when you code, you want the rest of your engineering team to understand what you write, because their code is probably going to have to interact with your code. For them to code, they have to understand exactly what you are doing, right? There's a lot of interaction there between code from different people, which is why it is important that, again, it stays declarative and readable, right? This is why it's super important. I remind the residents all the time that you code not for yourself, but with others in mind, right? What you want is other people, like your manager, like your colleagues, like your mentees, right? Your junior software engineers that are under you, to look at your code and think like, wow, this software engineer knows exactly what they're doing. Their code is clean, declarative, super easy to understand. That is exactly what you want. Now, before we keep kind of fantasizing about you all becoming like senior engineers in these like massive companies, right? You're here with me tonight, right? So if you plan on continuing forward with Codesmith and kind of like forging your way into this industry, a hot tip is that these higher order functions are the backbone of the technical interview in order to get into our program, right? This is why I'm here, to help deepen your understanding, kind of like set you up for success when you get that technical interview. All right, sounds good? Can I get thumbs? All right, perfect. So let's do it. Let's start with some JavaScript principles. So the code that you see here, right here on the right, right? We're going to break it down and spend a lot of time with it, so you know exactly how this piece of JavaScript code works. We're going to be doing a lot of diagramming tonight, right? We call this hard part style. It's very like Codesmith, hard part style, where we break down what is happening under the hood. So you get an idea of how our JavaScript code is executed by the browser. Now, of course, before we dive in, let's again first visit these foundational JavaScript concepts. So, in the most basic overview, JavaScript is single-threaded. Anybody know what that means? That JavaScript is single-threaded? Adam, might you have an idea?
It only does one thing at a time.
It only does one thing at a time. Absolutely. It only does one thing at a time. So that means it is synchronous. That also means that it goes through our code line by line in order from top to bottom, left to right, right? Like when you're reading a book. I also kind of like the analogy and imagery of like a spider kind of like working its way down from the ceiling, and you can kind of like slowly see this like delicate thread kind of like following as it like lowers down, right? There's just like the single thread kind of following all the way down, right? So it's the same as how, again, JavaScript is single threaded, going lower and lower line by line. This is the concept of this thread of execution, right? The thread of execution. This tells us that this thread of execution, JavaScript goes line by line and does whatever that specific line of code says to do, right? So our thread of execution, just like that spider, will typically go from top to bottom, right? That is the rule of the thread of execution, especially when you're dealing with JavaScript. All right, so along the way, as it is going down right here, right, as this thread of execution goes down, again, it goes line by line, and along the way, it's going to encounter different things. So for example, the first thing that it encounters here is a variable. Now we know it's a variable because there are certain keywords that signals that to us, right? We see the keyword let, we see the keyword const, right? These are all keywords that signal a variable, right? Can anyone tell us what is a variable? Kaylee, would you know what a variable is? It's
A
okay.
variable. I don't know a good definition. I know that it's a like definition of something that's stored in memory.
You absolutely got the keyword, stored in memory. Thank you so much. So a variable, right, just allows us to store important information or data that we want to access later. So in this case right here, let num equals 3, right? Let signals, okay, this is a variable, right? And then we're saying we want to store the number 3, and we are going to assign it to this label of num. So just like you would store something in like a pantry, right? We stick a 3, pretend 3 is a cookie, we stick a cookie, we put it in a jar, and we label the jar cookie, then we put it in a pantry, right? Same idea. So this is just, again, important information that you want to store, you store it in a variable, and that variable gets stored somewhere, all right? Now, along the way, right, now we see some lets, we see some consts, those are variables, but we also see this function. And I think it's kind of obvious that the keyword function probably indicates that we are dealing with a function. So again, we know it's a function because it uses the keyword function. And this function in particular, we have labeled multiply by 2. That is its name, that is its label, right? Now we talked about what a variable is. What about a function? What is a function? Mary, what do you think?
Functions, what I know, it's just like the block we create and can reuse. It can be reused.
Yes, absolutely. I love she's hitting on some. Thank you so much, Mary. She's hitting on some keywords here that we are going to be exploring much later. But she's saying it's a block of code, right, that can be reused. So a function certainly is a block of code, and it is a set of instructions that tells the computer how to do something, right? In this case, our function multiply by 2, right, with these instructions, which, you know, this is the definition right here. These are the instructions. We give the computer these instructions and we tell it, okay, if we want to multiply something from by 2, this is the logic in here that you are going to execute, right? So again, it is just a set of instructions that tells the computer what to do. Computers, people say like, oh, computers are smart. It's actually not true. Computers are actually dumb. You know, they don't quite know what to do unless a human tells them what to do, unless an engineer writes the code that tells them, okay, if this conditional is met, this is what you do, right? This is what you, this is the functionality that you're going to perform at this time, right? It needs instructions, and a function gives it just that. So in this case, right, this function just gives us instructions of basically taking in one argument, right, an input number, and then multiplying by 2. So we take an input number, we multiply it by 2, and then we return the result. So again, just like how we store variables to access important data, like the number 3 later, we can also do that for function definitions. So when you use the keyword function, right, you are just defining the logic and the functionality and the set of instructions. Right here, we're just defining the logic, right, for our instructions. And then what we can do is we can store that definition with those variables so that later, right, just as Mary said, it's something we want to reuse over and over again. We can access it whenever we do want to reuse it. And this is great because it allows us to follow something we call the DRY principle. Anybody know what DRY stands for? The acronym DRY stands for. Anybody know what that is? Erica? I think I saw you nod your head.
I think it's like do not repeat yourself.
Exactly. DRY stands for do not repeat yourselves. I mean, in real life, it's actually one of my like pet peeves, right? Like my mom, oh my gosh, she'll just like repeat things again and again. Did you take your vitamins? Like, what is this again? What time is your flight again? It's like, Mom, I already told you this. Like, I don't want to keep repeating myself. Can you write it down or something? I try to be very patient, but thankfully, this is not a pet peeve when it comes to teaching. So I don't want you to think like she's not going to want to repeat it because she's already said it. No. Teaching, I will repeat something over and over again until you get it. Just my mother maybe is the person that I that I have a problem with this with. But yes, nobody wants to repeat themselves, right? We want to do something once and we want it to stick. So earlier I mentioned why we really want our code to be declarative and readable. But like Mary said, we also want it to be reusable. If you have a function, you declare it, you define it once, and you save it, and so you can reuse it again and again whenever you need it. All right? So right there, functions. Now, I keep talking about storing variables and storing functions, and you're probably like, okay, Katrina, where are you storing these things, right? Like, what is the equivalent of that pantry you were talking about? Well, that is, my friends, memory, right? Memory is also known as variable environment. So this is where anything defined as a variable and a function is stored until we are ready to access it. All right, so keep these principles in mind. How do we feel so far? Are we good? Perfect. All right, so let's move into the fun part, the diagramming part. Okay, so this should look familiar for those of you. Oh, yes, Ronald, is that a question? Is that a question?
Yeah, I just had like this question, because I've always been just curious about it. Like,
Sure.
so I know when like the interpreter like reads, or my understanding is like when it sees that let keyword, it's like, okay, let's create a variable in memory and we'll label it num or something like that, right?
Yeah.
And then when it sees that function keyword, it's like we're going to create a function in memory, and that label is multiplied by 2. Is
Yes.
that label and the function, is that like, I know the value of that label is a function, a reference that points to multiply by 2, but like, is that multiply by 2 label like just a variable that has the value of a function? Because
So it stores the function definition. So it points to, it references, right, multiply by 2 stored in memory. And you're going to see this when we diagram it out. When you save it in memory, you're going to give it that label of multiply by 2, and then you're going to assign it the function definition. Everything that I noted here, right? This is your, oh, that is black on black. That is not helpful. So right here, right? This is our function definition. So that is what it is assigning to that label. So then by the time that you get to a part of your code where you actually invoke it, it looks for that function definition, right? And then it starts to run it.
Okay.
All right. So maybe hold off on more questions like with regards to this topic.
Okay.
Let's diagram it out, and then we'll see, because we're kind of going to break it down little by little. So let's see if you can get a better understanding of it. Yeah. And I'm going to check back in with you. All right. So this is our global execution context. This entire page that I have on here, this is the global execution context. And this is what holds the entirety of our code. This is all we have for code, right? This is our complete code. Our global execution context holds this thing, right? So there are 2 important things that need to happen when our browser executes our code line by line following our thread of execution. So first thing, we need a place to store and write information, right? So let's just, I just want to make a note of it. So we need a place to store information, and we also need a place to kind of keep track of what's happening in our code, right? So track our execution contexts. Execution context. Basically the space where we are executing any code. Contexts. All right, so these are the 2 things that need to happen. So, like I mentioned earlier, right, we are diagramming through this piece of code, right, hard part style. So we're gonna need to set, knowing that our goal is to store and track our execution context, we need to set a few things up for our global environment. So where did we say we store data and function definitions? Neil, where did it say that happens?
Can you hear me?
Yes, I can.
Would it be stored in the global variable environment?
Yes. Sorry, I'm just really, oh my gosh, I want this, like, you know how like I want this to, yes, you see that? It straightened everything out for me. Thank you so much, Neil. Absolutely. We store everything in our global memory or global variable environment, right? So right here. All right. Now, does anyone know where we might keep track of what execution context we are running? Right here in this corner. Does anybody know what I'm referring to down here? Oh, Ronald's giving me a head nod. What is it, Ronald?
I believe it's like the call stack.
Yes, correct. We have a call stack. And this call stack, as you are going to see as we move forward tonight, right, this is going to keep track of where we are in our code given the different execution context that we might push in and pop out of our call stack. So, Ronald, since you knew what a call stack is, do you know what is always at the bottom of our stack?
The global execution context.
Exactly, right? Because this is kind of like the outermost execution context that holds everything. So it is always at the bottom, right? So revisiting what I said earlier, right? JavaScript and its engines are single-threaded. Code is executed by the browser line by line. Somebody mentioned that it is synchronous. Adam mentioned it is synchronous and can only manage a single sequence of tasks at a time. Now, when a language is single-threaded, it probably also means that it also has one single call stack. All right. So, anybody else besides Ronald? Does anybody else besides actually, I already explained it. I was going to say, does anybody know what a call stack is? I already explained that it is what keeps track of the execution context. So let's dive into the actual code, right? Actually, one last piece that I am missing right here is our thread of execution, which again tracks of where we are line by line, right? This just tells us, okay, follow this line as we go through your code. So we are in the global execution context. That is where our thread of execution currently is. So, who wants to practice their technical communication? Who is my first? Diana, yes, so proud of you. Let's do it, girl.
All right, so the first line, you're going to declare a variable num.
Yes, perfect, go ahead.
And then using the keyword let, and we're going to store that value in the global memory.
Perfect. Right, so this is our global memory, and now we are storing it num equals 3. Perfect, okay.
And then we're going to create a function called multiple by 2 that takes in a parameter input number.
Okay.
And we're going to store that in global memory as a function.
Exactly. So we are going to store the definition of multiply by 2, right? Just its definition in memory. All right. What happens next?
And then we're going to declare a constant output, and it's going to equal multiple by 2 with the argument num.
Okay. So we jumped right. So I just want to point out, right? We did not run this code yet. We just stored it. We just stored the definition in memory, which is why we jumped from here to here, stored this, and then we are jumping down here. So output, like Diana said, we store it in global memory. And what is the value of output, Diana?
It is the, I guess, is it the execution of multiple by 2, the argument num?
Yes, it is the evaluated result, right? We still have to figure out the result. It is the evaluated result of multiply by 2 passing in the argument num. Absolutely correct. So what happens? What is happening here? What do we do now? What do we have to do here now? Once we're
going to open up a local execution context.
Exactly. So that means, right, that we are invoking multiply by 2 right here. We are invoking, this is the time where we actually run that function. How do we know that we are actually having to invoke this function, Diana?
The parameters with the argument.
Yes. So it's this, right? Every time you have a parenthesis, right? Sometimes there is no parameter, sometimes there is no argument. But when you see the name, the label, and parentheses right here, then you know it is being invoked. And then, as Diana said, right, this is the time that we are opening up a local execution context. Wow. Sorry, I'm really counting on Notability to like, it does this thing where it like senses what you're trying to draw, yes, and then it'll just like perfect it for you. So I was trying to draw a box, it recognized it, popped it in for me. So yeah, glad that was successful. So this is now our local execution context, right? So now that this is open, what are some things given all the other parts of our global execution, what should happen with the rest of the items right here? What happens to our thread of execution, for example?
So with the thread of execution, we're going to add the local execution context on top of the call stack.
Right. So thread of execution enters this local execution context, right? And as she said, we push in, right, our multiply by 2 right here, right? Because we are entering this function within this global execution context. So global execution context, right, it holds everything. And then once we reach the invocation of the function, we need a dedicated space for that code block of our function to run, right? So that's why we have to open up a local execution context. What is within this local execution context?
So the parameter is num, and we know num is equal to the value of 3 because of global memory.
Okay, yeah. So where does that go?
That would go, I guess, in local memory.
Yes. So within our local execution context, right, there is also local memory. So anything that is happening within our function, right, any variables and function definitions, right, get stored in local memory if it is within the local execution context. So the first thing that Diane said, right, is we pair the parameter, right, with our argument. So what was our parameter?
The parameter is input number.
Parameter is input number. Okay, and what is it assigned to?
It's assigned to the value of 3.
Yes, exactly. So input number, right here, this is our parameter. We pair it up with the argument. The argument is num. And right here, we see that we have stored num as having the value of 3. So that is how we got input number is equal to 3. Okay, and then what happens?
So, and then we would declare a constant result in the local memory.
Okay.
And that would equal our parameter times 2.
And what is our argument?
The argument would be 3 times 2. I mean 3.
Yep. So 3 is our argument, and we multiplied by 2, right? It's referring to this part, right? What is the result?
6.
6, and then what happens?
And we return result. So our the execution context would return 6 out.
Yes, and where does it return it to?
And then it go to global memory.
Global memory, and where is it assigned to?
It's assigned to output.
Exactly. So this right here, when we return it, this gets put or assigned to output right here. This is where we get 6. Okay, and then what happens to the rest of the parts right here that we have?
So the local execution context would get garbage collected, and then the call stack would get rid of multiple by 2.
Yes, exactly. So our thread of execution, right, as we were running the code within the function, right, goes within it. And then when we are done, when we return out, we move that thread of execution moves out of that local execution context. As she mentioned, right, this gets garbage collected, right? And then, like she said as well, that multiply by 2 function, that gets popped off of the call stack. Absolutely. Everybody follow with that? Thank you so much, Diana. All right. Yes, James giving you a round of applause. Very well done. James, since you appreciate it so much, would you mind walking us through new output? Right here.
Sure. So new output is also going to call the function multiply by 2. and open a local execution context.
So what is the, hold on one second. So new output, where does new output go? There's a const in front of it. So what happens to it?
Right, so this is a new variable that's going to be stored in global memory.
Perfect, okay. All right, and then?
And then in order to determine the value that's going to be assigned to new output, it's going to call the multiply by 2 function.
Yes.
Opening a local execution context and local memory.
Correct.
This time the parameter input number is going to take the argument 10.
Okay.
And it's going to multiply that by 2.
Okay.
Yielding 20. And then it's going to return that result of 20 back to the global execution context.
Okay.
Where it will store it as the value of new output. And it will garbage collect this local execution context and memory.
Absolutely. All right. One thing we forgot was that when we open up this local execution context, right, then it gets popped onto here, right? Multiply by 2.
Onto the stack. Yeah.
Yep. Sorry, I forgot to write it. And then once we have returned our results, right, and now we have new output and its evaluated value, right, then everything else is garbage collected, right? So our thread of execution, when we open this, thread of execution entered right here, ran all this code, exited when we returned, and then when we returned, we also popped this off. And just as Jeff said, we exit out, or we garbage collect this execution context, right? Did everybody follow that? Wow. Everybody follow that? Anybody have any questions? Okay, awesome. Thank you so much for those who participated. You guys were awesome. Awesome work on the technical communication. Yes, Ronald.
Yeah, I just wanted to clarify, like, you know where it says const output is assigned the evaluated result of invoking multiply by 2, passing in the argument of num. Num needs to be evaluated, right? Or resolved to the whatever value it contains, and then it can be invoked with that value, right?
Yeah, exactly. So it sees num, right? It gets to that line, it sees num, and it's like, ooh, what is num? Where is num? So then it looks in our global memory, right? And it finds the label num, and it's like, oh, num is equal to 3. So then it kind of replaces that, right? 3, and then it pairs with that parameter, and then passes the 3 as an argument. Exactly.
Okay, thank you.
Yeah, of course. Anything else? Okay, awesome. So we have a lot more diagramming to do, so let us move forward. So let's talk about functional programming. So all these concepts, right, together allow us to jump into something called functional programming. Basically, it's just a way of programming where programs are basically constructed by applying and composing different functions. So some essential features of functional programming are pure functions is one of them. Pure functions. Can anybody define what a pure function is? Mike, do you have an idea?
As to what a pure function is?
Yes.
It's a... Oh man.
If you don't know.
Yeah, I'm not too sure. I think a pure function is just something, well, as it says right there, no side effects. So you define it, so it'll just like run what you tell it to do. And so it won't have any like other like random variables going on or whatever. Yeah, I'm not too sure.
Yeah, no. First of all, kudos to you for using the slides as a resource. Love it. Yes. Irene, did you want to add to that, or do you have a question?
Yeah, I wanted to say that it's a function that doesn't accept another function as an input argument.
Yeah. So a couple of things when it comes to pure functions, right? And And Irene and Mike both like hit a couple of important points. So 2 things here. When you have a pure function, given the same input, it will give you the exact same output every single time. So in our previous function, right, we had multiply by 2. If our input is 3, it will always spit out 6. If our input is 10, it will always spit out a 20, right? Given the same output, we can always predict the same exact output. And just like Mike said, right, inferring from what it says here, that says no side effects, we are not affecting or changing anything outside of that function's execution context, right? So we're not affecting outside variables, outside functions, anything like that, right? So no side effects. Exactly. Thank you so much to you too. So another essential feature are, again, higher order functions. Higher order functions, these are valuable tools that you should have in your toolbox as an engineer. And like we mentioned earlier, some of them are built into JavaScript, right? Just like filter, map, reduce, these are built in, right? These are not some that we write, because we can write them, we can design them. Some of them are actually also built in. So they give us more declarative, more readable code. And like I mentioned earlier, it is a big part of your TI, so just keep that in mind. Yes, Aram, is that how I pronounce your name?
Aram,
Aram, yes.
when you're talking about side effects, is that the same thing as closures? Does it involve, is there anything other than closures involved in side effects?
Side effects, so this is kind of outside of the scope, right? Because I don't want to confuse people that haven't gotten the concept of closures. But typically when you are affecting, because with closures, right, you are accessing outside variables, right? So there is kind of side effects going on there, yes. But with pure functions, right, you don't want to affect anything else. So a lot of the time, I'm trying to think of a way to explain it without kind of like going into a rabbit hole. But yeah, basically what I want you to think about is you have your function scope, and as long as you are keeping everything contained within that, right, all you are affecting are the variables within that function scope, then you have a pure function. Does that answer your question? Okay, perfect. All right, so why do we even have functions, right? So let's see why. So let's create a function 10 squared. It takes no input and returns 10 by 10. Aram, since you turned on your camera for me, sorry to do this to you, but would you like to create this function for us? It's going to be quick and painless,
Sure.
I promise.
So create a function 10 squared. So function.
Yeah.
I'm just talking you through the code, right? So function, and then we can call it.
How would you write this, or how do you want me to write this?
I would write the word function.
Okay. Wow, I don't know my function. Okay.
And then I can call it 10 squared.
Awesome. 10 squared.
And then I'll open up the curly. Oh, wait, no. I want to open up parentheses. Oh, wait, takes no input. So yeah, open and close the parentheses right away.
Right, there is no parameter, correct. And then what happens?
And then I'll open the curly brace.
Mm-hmm.
And I'll go down a line, indent. Oh, and that's all it does. So I want to write return.
Okay.
10 asterisk 10 semicolon.
Wow, thank you so much. I like how you were even specific about the formatting. You're like, let's indent that return, please. I love that. Good job. Yes, so this is the function that we would write for this, right? So thank you so much. So we have function, a keyword that indicates it as a function. We have labeled it 10 squared, right? It takes no parameters, and so this is why there is nothing within our parentheses, right? And then all we are doing right here is returning 10 by 10. So then what happens is we invoke 10 squared, right? 10 squared, right? We invoke it, and we know that we are going to get 100, right? Everybody follow that? Everybody see what's going on? Perfect. All right, thank you so much, Aram. All right, now let's create a function that returns 9 squared. How about Dylan? What do you think? Let's tell me what to write. How do we write this code?
I would do it just like the last guy did. I would write function first,
Okay.
and I would write out I would write out 9
Mm-hmm.
squared,
Okay.
and then space open curly brackets.
Open curly brackets already?
Oh no, my bad. Parentheses, open parentheses, close parentheses.
Exactly, right? So we don't
Yeah,
have an input, so nothing within the parentheses,
right.
okay?
And then space open curly brackets.
Okay.
Then there you go. And then go to the middle line and then put return space 9 times 9.
Perfect. 9 times 9. All right. So again, we invoke this, and then we know that we are getting 81, right? Perfect. All right. So we did it for 10, we did it for 9, and now we are going to do it for 8. Very repetitive. You guys are getting bored. You're like, really? We're going to do it for 8? It's pretty much like writing the exact same thing. Can you we saw you copying and pasting earlier. Can you just do that again? Change the numbers inside? What is going on? Exactly. Remember earlier, we do not want to repeat ourselves. So what principle are we breaking right here? Just by writing again and again, kind of putting those values inside of the function. It's not reusable, right? What principle are we breaking right here? Yes, Jana.
The dry principle?
The dry principle, of course, because y'all are making me write things again and again. This is not, so dry is a principle that we talk about. It's an official thing, but this is just a me thing. So don't repeat this to any other, but I like to think of it the opposite of dry principle is the wet principle, right? Which is we enjoy typing. So it's me typing code again and again and again, right? So that is the wet principle. You just enjoy typing. It's not good to enjoy that much typing. I do not want to be writing this much. I do not want to be typing this much, right? So that being said, let's save ourselves. How do we fix this? Clearly, we are using the same logic when we want to square a number, right? Same logic, 10 by 10, 9 by 9. So is there some way, is there a function that we can write where we can make it reusable? Can somebody give this a shot? Yes, how do you say your name, sir?
Marcellus.
Marcellus. Yes, Marcellus. Let's do it. Oh, before you proceed, Akul, was that a question or was that volunteering to? Oh, volunteering. Okay. I'll get to you. Don't you worry. Yes, Marcellus. Let's go ahead and write this function out together.
Are we doing the 8 squared function or the one that doesn't repeat itself?
Let's do 8 squared, but we want to make it adhere to the dry principle.
Oh boy. All right.
Not what you volunteered for.
I was ready to just repeat what everyone else was doing. Yeah, I was ready for that.
Let's walk through it, right? Let's walk through it and see if we can get to a point where it's okay, we can plug in some numbers here and it'll change depending on what we plug in. How about that?
Yeah, let's go with that. You want to create a function, let's just call it squared.
Sure. Function squared, okay.
And it will take.
These are not our instructions anymore, right? These are not, we do want to return what 8 squared is, but don't pay attention too much about what this is, right? Because this kind of goes back into the non-dry principle. So squared, does it take an input?
Yes, it does take an input. And I believe that input would just be num, so just one number.
Yeah. So this is just a placeholder, right? This is our parameter.
Yep.
Perfect. And then
We would, if you want me to explicitly state, we'd have the curly
no,
braces.
just do
Yeah.
high level. Yep.
Okay. Then we would return num times num.
Oh, I do not know how to spell num, apparently. Okay, return num times num. Okay. All right. And then what? How, if we wanted to return 8 times 8, like, how would we invoke it so that we make it do 8 by 8?
So we would just, to invoke it, we would just do squared with the argument of 8.
Passing in the argument of 8. Perfect. So when this is invoked, right, our argument will pair with our parameter, right? So this becomes 8. And then effectively num, and num becomes 8 times 8. And then ta-da, we return, what is 8 by 8?
64.
64, yes. All right, yes, exactly. So thank you so much. Awesome job. So basically what we did here, right, to make it reusable and make it adhere to that dry principle is we generalized the function, right? So we don't need to kind of like hard code those numbers that we are working with inside of the function, right? Because for the earlier iterations of our code, we had like 10 by 10, we had like 9 by 9, right? There's no room for kind of like reusability and flexibility. So by adding, again, a parameter and also an argument, right, we can basically customize how this function runs and what kind of values it is dealing with at any given time. So I know we already kind of like pointed it out earlier, but let's see, Isaac, what is our parameter and what are our arguments right here?
Our parameter is num and our arguments are what's being passed in. So 10, 9, 8 in this instance.
Absolutely, right? So these are our arguments. Exactly. So again, our parameters, right, are just placeholders. We don't have to decide what data to run our functionality on, right? We don't have to decide right at the get-go when we define our function that like, oh yeah, this function will run only for 10 by 10, 10 times 10, right? Or it's only going to run for 9 times 9, right? What we do is we keep it general and we use that parameter as a placeholder so that when we invoke our function, like we do down here, when we invoke it, that is when we are passing in different arguments and we are in effect able to kind of like customize, right, what data our function is working with, all right? So this is also why, right, when we open up that local execution context for the first time, the first thing that we do is we pair up our parameter and our argument so that we know exactly what value we are working with in our function. So again, in order to keep our code reusable, keep it dry, all we need is this generalized function so that we can basically reuse the same logic but for different inputs and different arguments, all right? Now, higher order functions, right? Higher order functions follow the same principle. We may not want to decide exactly what our functionality is until we invoke our function, right? So let's see what that looks like. Before we move forward, how is everybody feeling about what we have so far? Everybody see how that works so much better? Okay, awesome. So now suppose we have a different function. Suppose we have a function copy array and multiply by 2. Let's diagram it out. You know how much we love diagramming. So let's set up our environment right here. Adam, what do you think? Would you like to talk us through what parts we might need?
All right. Okay, let's do it.
Yeah. So what do I need for
So let's see. We'll need a call stack.
Okay.
Need a thread of execution, global memory.
Perfect. And we have, oh my gosh, I really want these to straighten for me and they're not, but like I'm just trying to ignore it. Like my inner, you know what I mean? Like
it's unique.
It's driving me insane. The squiggly lines, but I'm gonna hold on.
They look good.
Thank you. All right. So, and we have what helps us keep track of where we are?
So we need on the call stack, we need a global
Yes.
at the bottom.
And what helps us keep track of going down line by line? The spider silk, if you will.
The toe?
Yes.
The thread of execution?
Our toe, thread of execution, spider thread, yes, thread of execution. So right now our thread of execution is in the global execution context. Would you like to continue and walk us through this code?
Sure, that's great. So we're gonna go top down since it's single threaded. We have the first line function copy array and multiply by 2. And we will put that, yep, we'll put that in the global memory. That's right, with the function definition.
Okay, function definition, perfect. Sorry, I did look a little shorthand for the name.
Nice. Then we'll skip over that to, let's see. Gotta get past those. Okay, so then we go to const my array.
Okay, and why do we bypass the rest of it?
Because that is all in the function definition.
Exactly. Perfect. All right.
It is being stored in global memory, and it hasn't been called yet.
Exactly.
So then we have const my array. That's a label that's also an array being stored in global memory.
Okay.
Of 1, 2, 3, and then we move on, and we have result declared in the global memory with, and then we will invoke copy array and multiply by 2 with the argument my array. We'll move on up and start executing that first line.
Okay.
Awesome. Passing in my array into the parameter of array.
Awesome. All right. So in our global memory, just to make it clear, right, our result is still kind of like on hold because it is waiting for that evaluated result, right? The invocation. Perfect. All right. So this is our local excuse me. This is our local execution context. And what do we need in our local execution context?
We need a memory, a local memory.
Of course. Perfect. Okay. And what happens to our thread of execution?
We need a call stack. Well, we move the toe, the thread of execution into the local execution context, and we actually have a call stack started there.
Perfect.
Copy the cam-v2.
Okay, and then what happens?
And then we pass in my array, which is the parameter array, into line 1.
Okay.
The function cam-v2. So we have in there const output equals empty array. Yep, empty array, and that's being placed into local memory. Nice. You're beating me.
There we go.
Nice. Thank you. And then we're going to line 3, which is a for loop. We're going to set I to 0.
Okay.
Which is
Actually, hold on one second. Is everybody super familiar with for loops, or should we maybe let's just revisit it for 1 second, right? Just in case there are some of you that aren't super familiar. So Adam, hold on to that for a second. So typically, right, for a for loop, you have different parts of your for loop, right? So as Adam was already like indicating, we actually have our keyword for, which tells us that this is probably going to indicate like a for loop. So our keyword for, so we have these different parts right here. So let I equals 0, that is our initialization. So this happens only once. We initialize I and we set it equal to 0. And what does 0 mean in the context of our array? So we have an array of 1, 2, 3. Does anybody know what 0 is referring to in the context of our array? Marcellus, you were nodding your head. What is it?
Oh, the index.
The index, yes. And so what is the index of 1 in this case?
The index of 1, of the number 1, and
yes,
it's 0.
Yeah, exactly. Right, and then we increment through that. Perfect, thank you. So arrays, right, start at index 0, and the placement of every element is noted again by that index, right? And so the number 1 is at index 0, number 2 is at index 1, number 3 is at index 2. And again, this right here, let I equal 0, we're just initializing I, meaning like this is where we want to start the loop. In this case, we want to start the loop at the very first element, right? Whatever is at index 0, we are starting the loop at the very first element of the array. And then the next part of our for loop, right, is this condition. This is where we check, okay, right, is I, which is currently 0, right, is I less than array length, and then we check to see if that condition is true. If it is indeed true, then we go into our statement execution, where we actually execute this piece of code within our for loop, right? And then finally, the last is basically our final expression, where we tell our code how to iterate through the array. Yes, Aram, do you have a question?
Do we have to use dot push to create the index? Is that?
I'm sorry, say that again.
Do the indexes exist as soon as you declare the array, or are the indexes created as you use dot push?
Yeah, so when you create, you do not need push. Push is just a method that you can apply on your array, right? So it is built into JavaScript, like push as a method, right? But when you declare your array, when you define your array, right, under the hood, right, it already assigns those elements to a specific position, which is our index. Does that clarify?
I think so. Well, are there if it's an empty array that like output is, does it get indexes assigned to it right away? Is it allocated some memory, like indexes in memory right away, or do you have to like allocate those as you go?
I'm sorry, I'm misunderstanding your question. If you had what?
Sorry, maybe I should just research it later.
Can I put in here? Are you asking if the indexes exist in the array before there are actually any elements in the array itself? Like if you had an empty array, are you asking if there are actually indexes in there?
Yes.
Yeah? Okay, the answer is just no. So like if you had an array and you said like array at the index position of like 0, it would return undefined because there's nothing there. So the answer to your question is just no, it just doesn't exist.
Is that why we have to use dot push instead of being able to do like output at I equals array at I times 2?
So the reason you would use dot push is just a choice of the engineer when you're regarding to say sorry, by the way, sorry, thank you so much, Tristan. Yeah, I was not quite understanding the question. But that is correct. If you are accessing that 0 index, absolutely undefined because there is nothing there. But with regards to your second question, and let me see if I understand this right. You're asking why we are using push. So push, right? It's just a choice of how your so in this case, we want to copy the array, right? We don't want to mutate our original array because arrays, this goes into like how arrays are composite data types and how those are typically like passed by reference. So if we could mutate, right, the original array. However, in this case, we want to copy an array. And the way we would do that, right, is we would start off with kind of like this blank array right here, this empty array, I should say. And then we can kind of do functionality that basically does not mutate the original array. And we are basically doubling, right? We are doubling each element of this array and then putting it into its own array. So the choice of using push was because we wanted to copy it. So as long as you understand like what methods you can use for each case and like depending on what your goal is, right, then you can do that. Does that kind of clarify why we kind of chose push in this case, because we're making a copy?
Yes, thank you.
Perfect. All right. Okay, so everybody clear on kind of like the parts and how for loops work? I know I got a lot of thumbs earlier, but I just want to clarify just in case there were some people that weren't sure. Okay, perfect. Adam, sorry to have interrupted you. Let's go back to that for loop.
Cool. No, that was great. So we have let I equal 0.
Okay.
Very good. And then we're just going to go through it for the length of it.
Okay.
I being less than that length of the array, which is going to be 3 of them.
Yeah, so the length of the array is 3, right?
So that's going to be our conditional.
Perfect.
And then we go to the third part of that for loop where we increment it up until the condition.
So before we increment, we have to execute that functionality first. So output.push array of I. What is array of I? Array of 0.
Right. Yeah.
So what is array of I?
Array of I is currently 1.
1, and then we multiply it by 2, right? So we execute that first. And what is the answer of that?
2.
2. And then we push it into our output. So now we have 2 in here, right? That is the first thing. And then what happens?
And then we continue. We go to the next index, which is 2.
So now we go into this incrementation, right? Okay, perfect.
Well, actually, the index of 1 being the value 2.
Exactly, right. So, and then what happens? We check our conditional is 2, is I, which is 1, was 1 less than 3?
No, so we should continue.
I'm sorry?
No, we should continue.
Is 1 less than 3?
Yes, I'm sorry.
Yeah, okay. I just wanted to double check. Yes, it is, in fact. So we execute, right?
Right.
All right. So what do we do next?
We are going to now go to index 1, which is the value 2, and multiply that times 2.
Correct.
And we get 4.
4.
And we'll push that in.
Perfect.
And then we will continue with the for loop.
Okay.
All right. We still are under the condition that it is less than the length. So we push, we'll do the multiplication 3 times 2, and then push that into the 6 into the new array.
Okay. And then what happens?
And then we've met our condition in the for loop. So we exit out of that and we move to the, I guess, maybe 7th line.
So we
return
increment
output.
this first, right? It reaches the index of 3. Sorry, I'm trying to get granular just for people that might not. So we increment, right? We get to this point, we increment I to the next index, right? So now we're at index 3. And when we check for a conditional, 3 is not less than 3. And that is why we exit out of the for loop. And then once we exit out of the for loop, what happens?
We hit the jackpot.
Perfect. We hit our output. I got you. We return our output, right? And so our output right here goes right here into
the local memory.
Yep.
Oh, and then the global memory. Yeah.
Yeah. Okay. So did everybody follow what happened right there? Did everybody follow that? Okay. Awesome. All right. So just to quickly talk. I'm so sorry. Adam, did you say something?
No.
So when we returned, right, so our thread of, Adam walks through the entire thread of execution within our local execution context, right, up until the point of returning our output. And then once we returned, our thread of execution leaves our local execution context, right? So this effectively gets garbage collected. That is an official term in case you didn't know. So this is garbage collected, and basically this that function gets popped off of the call stack, and now we are back in our global execution context, and we have reached the end of our code. All right, everybody see what happened? Okay, Alina, yes, you have a question?
Hi, yeah, I just wanted to, I missed, I'm looking for how to describe it technically. If you go back to the thread of execution that you just quote unquote garbage collected.
Yes.
The
Would it be helpful if I went back to the diagram?
Sure.
Okay, let me just.
Thank you. Yeah, so I missed how you would describe technically when we get to the point where we open this new thread of execution, and then the first thing we do is we save the my array variable to the array parameter. Is that how you would describe that?
So a couple of things. So we open the local execution context, right? I think you said we open the thread of execution. So we open the local execution context, and our thread of execution enters that local execution context. And the first thing we do, as I mentioned earlier, right, is we pair our parameter with our argument. So in this case, right, we pair our parameter array, right? We pair array, right, with my array. Oh, I'm so sorry. I actually had that backwards. Maybe that's what got you confused. Right here. Right here. So that's how you would technically communicate that. You would just say, I would pair, first thing we would do is we would pair our parameter with our argument, right? So our parameter is array, and we would pair that with our argument, which is my array, which is 1, 2, 3. Does that clarify?
Gotcha. Yes. Thank you so much.
Sorry about the mistake, guys, when I flipped the 2. Is that clear now?
Mm-hmm.
Okay, perfect. All right. Anybody else? Questions? Okay, awesome. So what if we want to copy the array and divide it by 2? So it looks similar, right? I've already kind of like set us up here, right? So we don't have to do that again. But it looks really similar to what we did earlier. The only difference, right, is we are dividing, right? Right here, we are dividing instead of multiplying. So let me just see how we are in time, and we'll determine whether we walk through this. Yeah, we have time. So let's have another brave soul walk us through this technically. How about DAT in NYC?
So we'll start with the first line of code, function copy array and divide by 2. We'll store that. We'll store the function definition.
Okay. Exactly. Function definition, yes. And then?
and then we'll skip down to constant, or we'll have a variable constant myArray, and that would equal to the array of 1, 2, and 3.
Yep. Okay.
And then we'll have another variable, a constant result, and that will equal copy array and divide by 2, passing through the argument myArray.
Yes, so we are declaring this variable result, right? But its value is going to be the evaluated result of invoking the function copy array and divide by 2, passing in the argument myArray. So what happens when we have this invocation?
You're gonna invoke the function copy array and divide by 2.
Okay. So what happens when we invoke?
Then you're gonna create a local execution context.
Yes.
And the toe is gonna weave into there, and we're going to declare a local memory and have the constant or a variable constant output empty array.
Okay, give me 1 second. So we have our local memory and we have our local execution context. And what happens to our call stack? What's at the very bottom?
Oh, the very bottom is the global execution context.
Perfect. And then where are we in now?
And then we just pushed on the function copy array and divide by 2.
Yes, I should have been doing this the entire time. So we could, there we go. Yes, local execution of copy array and divide by 2. Yes, and then?
And then we're gonna declare a variable output, and that's gonna set equal to an empty array.
Is that the first thing that we do? Remember, what is the first thing we do when we open a local execution context? What do we pair? Is that a good hint?
The argument to the parameter.
Exactly. So what happens? What are we pairing up here?
myArray to array.
Exactly. So our parameter array, and what is myArray?
myArray is going to be equal to array. Looks like.
So what is the value of myArray?
Oh, myArray. Oh, sorry. Yeah, that's going to be an array of 1, 2, and 3.
Exactly, because it looks for it, right? It looks for the value of this argument right here. So we're passing in myArray, and it looks for this value in global memory. And so this is the argument that replaces our placeholder array. Exactly. So we pair the parameter with an array. I missed that earlier. I made a mistake. So happy to clarify that now. Thank you so much. All right. So now that we've paired, what happens next?
We're gonna start the for loop.
We're still right here.
Oh, so we just declared variable output.
Okay.
And that's gonna set equal to an empty array.
Okay.
And then we're gonna do a for loop.
Okay, and we are going to be doing that on our
local execution context.
Just to remind everybody, these are our indexes, right? So we can better visualize and keep track of that. Okay, and then what happens?
So the for loop states we're going to initialize I at 0. The conditional is going to be the array length, and the incremental is going to be +1.
Okay, so we're for the conditional, just to clarify, right? We are checking to see if I is less than array length, right?
Yep.
Okay, so currently, right, I is at 0. Is 0 less than array length, which is what?
That is going to be 1.
Okay, so is sorry, I think I might have jumped ahead there. So array of length is 3, right? So array of length is 3, and then is I, which is 0, less than 3?
It is.
Okay, so then what happens?
And so we continue, and we're gonna do the next line of code, which is array at 0 divided by 2.
Okay, so what is that? What is array at 0?
It's gonna be 1.
Okay, and then divided by 2. Perfect. So then what happens?
And that's gonna get pushed into our output array.
Right. Perfect. So we have a 0.5 right here. Okay, and then what happens?
And then we're gonna increment our I to 1.
Yes. Okay. So
And then-
now is 1 less than 3?
Yes.
Okay, so then what happens?
And then we'll divide 2 by 2.
2 by 2, exactly. What is 2 by 2? And what do we do with it?
And then we'll push the results to output.
Yep, so that is 1. Perfect. And then what happens?
We're gonna increment it by 1 again.
Okay.
And that is still less than 3, or it is.
2 is less than 3, right? So we still meet the conditional.
And then so it would be 3 divided by 2.
Okay.
And then we'll push that result to output again.
Mm-hmm. Okay.
And then we'll check the conditional again. And
We check the conditional again right here, or what do we do before we check the
oh,
conditional?
we'll increment it by 1 again.
Okay, now it goes to 3, right? Perfect.
And then since 3 is not less than 3, we'll go down to the next line of code.
Exactly. Oh wait, first what, so to technically communicate that, what happens when we don't meet that conditional? What happens to our for loop?
The for loop is done iterating.
Yeah, so we just exit out of that for loop. Perfect. And then now that we're done iterating on our for loop, what happens?
We'll go down to next line code and we'll just return the output.
Okay, return output. Exactly. And where do we turn that to? Sorry, do you hear me?
Yeah.
Okay, so now that we return the output, right, which is this array right here, where do we return that to? Yoshi.
So the output will return back out. The thread of execution will read back out into global memory and return to results.
Exactly. So thread of execution, right, leaves that local execution context, right? And then that result is definitely going, that output, right, is now going to be right here, right? We've evaluated it. So result is 0.5, 0.1, and 1.5, exactly. And then what happens to our call stack?
The call stack will pop off the local execution context, so get garbage collected, pop off the call stack, and then return to the global.
Exactly. So now we have the evaluated result of result, right? So now we have this array right here, and then our thread of execution is back in our global execution context, and here we are back in our global execution context in the call stack. We pop that off. Everybody follow so far? Thank you so much, Dad. That was awesome. Thank you so much. Great job. All right. So now, so we did multiply by 2. We did divide by 2. So now let's do add 3. I'm just kidding. Let's not do add by 3. Can you imagine like doing that exact same code? That's like, no, thank you. So can you imagine like us walking through this again? We do not want to do that again. I will not subject you to that. I do not want to subject myself to all that writing. So again, this should feel familiar from earlier, right? What principle are we breaking here? Let's not break the what principle. So what principle are we breaking? Dry. Thank you, Ronald. Yes, we are breaking the dry principle. Do not repeat yourself. I do not want to repeat myself. We shouldn't be repeating ourselves, right? In code. So just like our solution from earlier, right? I'm so sorry, Alina, did you have a question? Sorry, I just caught your hand.
No, you got me before. Thank you.
Okay, yeah, no worries. Okay, so just like we did before, right? We could generalize our function so that we pass in our specific instruction only when we run the copy and manipulate our array, right? So kind of like what we did earlier, right? We generalize this, we keep it generalized, our parameter generalized, so that we can pass in more specific, more customized functions whenever we invoke the actual function, right? So this is an example of how we might do that, right? Actually, right here, before we start diagramming it out, compared to the two pieces of code that we last saw, it looks pretty much the same, but there is actually something that is different, that is new. Can somebody point out what is a little bit different? Yuri, I think I haven't called you yet.
Yeah, you didn't. So basically we're doing like a callback. We send in one more function. We're doing like double function. Like when we're doing copy array multiplied, we do like output push and we do instructions. So like instead of repeating like divide by 3 or plus 3 or whatever, we just like send in another instructions to not to repeat ourselves.
Exactly. So I like how Yuri just basically like summarized everything that we were going to diagram out, right? Thank you so much, Yuri. So the first thing, absolutely correct, right? Basically, we are going to pass in another function. So that is what is different right here, right? So rather than just passing in our array, we now see a new parameter called instructions, right? We now have a new parameter called instructions. Now we can name this parameter, we can name our parameters, our placeholders, anything we want. Just as a quick, like, why is it a good idea that we call this particular parameter instructions? Why do you think this is a good idea, right? Like, because we want to be declarative with how we name things, right? Like, we want to be semantic about our variable names and things like that. We want it to be meaningful. So why is it meaningful that we have named our parameter instructions? Why do we think? Sinclair, what do you think? Did you hear me? Sinclair, I think, is maybe ignoring me. It's okay. I will leave you alone then. What about David? What do you think? Why is it significant that we name this instructions?
Why are we naming it instructions?
Mm-hmm.
Because that's where that's our generalization, so we can vary whatever we want to do with the array within the function, and yeah.
So we name it instructions, right? Because it is basically a placeholder for a new set of instructions every time. And remember that a function is just a set of instructions telling the computer what to do. So we can call it whatever you want, but in this case, it makes sense because like we are going to pass in, right, an argument with a new set of instructions every time we invoke this function, right? So in this case, right, what we want to do is we want to copy the array, right? And we want to manipulate the array. And just like what David said, right, we can kind of be more, we can customize, right, what we are passing in, what kind of functionality we are passing in, and how we want to manipulate the array when we make an invocation, right? So let's go ahead, and who wants to, this might be the last piece of code we diagram out. So who wants to practice? Ronald, is that like I volunteer? Or is that a question? You put it down.
Yeah. I'd like to go if I can.
Perfect. perfect. I thought you like I called you and you're like, no, I didn't want. I wasn't volunteering for that. Okay, perfect. I love it. Please start us off.
Okay, sure. It's been a while, so let me see. So first, we're going to declare a function labeled copy array and manipulate
Okay.
in the global memory and save to it its function definition.
Perfect.
And then we are going to move down and then declare another function labeled multiply by 2 and save to it in the global memory its function definition.
Okay. I'm going to color this a little bit differently so we can distinguish between them. Perfect.
Okay, and then, sorry, I think we should also maybe put on the call stack our global, I mean, maybe we don't need to do that, our global execution context as our stack frame.
Yes. Look at you catching our, yes, let's do that. Perfect. Good catch. All right.
Okay, and then moving down, we're going to declare a constant labeled result and assign to it the evaluated result of invoking copy array and manipulate, passing in the arguments of an array which contain the numbers 1, 2, and 3, and the multiply by 2.
Okay.
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 Cool. And then, so yeah, we're saving that in global memory. And then we are then going to, since we're invoking a function, we need to open up a new local execution context for copy array manipulate. Oh my goodness.
Yes, sir. Okay.
Cool. And then we also need to push that stack frame onto the call stack. And then also our thread of execution is going to follow and weave its way in. And then we also, yeah, we need our local memory as well.
Perfect.
Cool.
Yep.
Cool. And then the first thing we need to do is handle our parameters. So in our local memory, array is going to be paired with the value of an array which contains the numbers 1, 2, and 3.
Perfect.
And then instructions is going to be paired with the function definition of multiply by 2.
Exactly. Everybody following so far? Great job. Everybody following so far? Perfect. Okay.
Cool. And then we're going inside of the function body and we're going to now declare a constant labeled output in the local memory and assign it the value of an empty array. Cool. And then we are going to then initialize a for loop. So then we are,
yep.
I guess I'll just go through it. Yeah. Should I just like read the 3 things? So like we're going to declare a variable I and initialize it as 0. And then our condition is as long as I is less than the length of the array, we're going to keep looping and executing our code. Yep. And then we're going to increment I by 1 every iteration.
Perfect.
And then within the body of our for loop, we need to push the result of wait. So I think actually I have a question on this.
Yeah.
So the way that we the interpreter reads this code is it needs to evaluate the expression in the very most like inner parentheses. So array at I would be the thing that's kind of like being evaluated first, right? And then it's moving outwards. Exactly. Okay, cool. Okay, so the way I'm going to approach this then is that first we need to access array at I. Just sorry about that.
No worries.
Yeah, we need to access array at index I, and I is currently 0, so that would be the value of the number 1.
Exactly.
And then we are going to
it's right here, right?
Invoke, yes, exactly. And then we're going to invoke our function labeled instructions with the value of 1.
Perfect. So what happens when we invoke it?
We also need to open up a new local execution context for instructions.
Perfect.
Yeah.
Wow, that is the best line I've done so far. It's a lot of pressure, y'all, writing all these lines. Okay, so this is now instructions, right? We've opened a new
Local execution context for instructions, right? And then it needs its own local memory.
Perfect. What else?
Yeah, and then we need to, or our thread of execution is going to weave its way into there, as well as we need to push that stack frame as well onto the call stack.
Yes. Okay.
Okay, so then what we're really doing, or visually, is instructions is the function formerly known as multiply by 2. So we can move our eyes kind of like down to the function label multiply by 2, and we are going to then handle our parameters. So input is going to be assigned the value of 1.
Yes.
Line of our local memory.
Yeah.
Okay.
Exactly. Yeah.
And then, yeah. And so then we're going to execute or evaluate input multiply by 2. And so input is the value of 1. So it's going to be 1 times 2.
Perfect.
And so we're going to return the number 2 out to where it was called.
Yep.
And that's going to basically basically the value that's going to be pushed into output is going to evaluate to the number 2, and then we're going to push the number 2 into output.
Perfect. Yes. Everybody follow so far. You're doing such an amazing job, Ronald. Everybody, yes. Okay, keep going.
Okay, great. And then after we execute that line of code, we need to increment our I by 1 as our final expression. So I is now going to be incremented to the value of 1. And then,
sorry, very quickly, I just want to note, like, this local execution context.
Oh, right. Sorry about that. Yeah.
Oh, no, don't apologize. I just wanted to point out that let's, like, just so I don't have to, like, write it over and over again.
Okay, yeah.
This basically, I'm just going to just do this, and that way I can just, like, eliminate it later. Yeah. So then, and then this gets, like, popped off. Right?
Yeah, it gets popped off the call stack, and this gets
exactly
closed, and then it gets garbage collected. Cool. And then we are then going to increment I by 1 as our final step for our for loop. And then we're going to check our condition again. Is I less than the length of the array? And I is currently 1, and 1 is not less than 3.
Absolutely.
So then we are going to go inside the body of our for loop again. And then we're going to evaluate array at index I, which is currently 1. So that points to the number 2, I believe. And then we're going to pass that in as an argument to the function call of instructions, which is then going to open up a new local execution context for instructions. And then our thread of execution is going to follow its way in, have our local memory. We're going to push that into the call stack, that stack frame. Then we're going to pair input, the parameter, with the value of 2. And then we're going to evaluate input multiplied by 2, which is then going to be 2 multiplied by 2, which evaluates the number 4. And then we're going to return the number 4 out to where the function was called. And that's going to be pushed into our output. So 4 should be pushed into the output.
Perfect.
And then also, we need to garbage collect that execution context, pop it off the call stack, that stack frame. And then our thread of execution is going to kind of like go back into the previous context, right? And then, or should I keep going, or should I?
Yeah.
More? Okay, cool.
Take us home.
Okay, cool. And then we are going to increment I by 1. So now I should be 2. Then we're going to check our condition. Is 2 less than 3? It is. So then we're going to go inside the body of our for loop once more, Then we're going to access array at I, which is currently 2. So that, I mean, index 2. So that points to the value of 3. So it's the number 3. That's going to be passed in as an argument to our call to instruction, which is then going to open up a new local execution context. And we're going to push that stack frame onto the call stack. We're going to have our local memory for instructions. Our thread of execution is going to weave its way into there. And then we are going to handle our parameters. So input is going to be assigned the value of the number 3. And then we are going to evaluate input multiplied by 2, which is then going to evaluate to 3 times 2, which is going to give us 6. So then we return the value of 6 from where we were previously called. And then that is going to be passed in as an argument to the push method, which is going to push 6 onto output.
Yes.
And then we also need to garbage collect our execution context. I keep going out of order. And then from the previous call, and then our thread of execution is going to come back in there. We're going to pop that off the call stack as well.
Yep.
And then I think we just need to increment I by 1, which will now be 3. And then we need to check our condition is 3 less than the length of the array, which is 3. So 3 is not less than 3. So then we will exit out of our for loop, and then we'll go to the next line and return the value of output, which is the array, which contains 2, 4, and 6. And that's going to be returned out to the global memory into the placeholder labeled result.
Exactly. So you put right here, oops, wrong, right there, right? And so,
and that needs to be like garbage collected as well and popped off the call stack.
yes.
Execution is going to weave its way in as well to the global. Okay.
Yeah.
It's a long process. Thank you guys.
Can we give Ronald a huge round of applause? Because that was so awesome, Ronald. Awesome technical communication. I know you said like, oh, it's been a while, but you did a phenomenal job. And you kept track of so many things. There are so many things that we are keeping track of here, like under whatever is going under the hood, right? You did a good job like keeping track of our thread of execution, our call stack, right? I was not able to keep up. Obviously, I did not pop that off until we were left with global right there. And then finally, we got our result. Everybody follow with how he explained it and what happened? Everybody? Awesome. I see. Thank you so much for the thumbs ups and the claps. Again, awesome work, Ronald. We have some questions. Is that a residual? Oh, cool. Yes. Sorry, I think I might have like butchered your name again.
No, that's okay. We missed the. I had a question when we are invoking, say, the last line where you're sent. We have copy array and manipulate, and you're sent. One of the arguments is multiply by 2. So when we invoke copy array and manipulate, are we passing it the label multiply by 2 or the actual definition? Do we actually copy the definition and does the definition of the function now reside in the local memory of copy array and manipulate? Because if, as far as I remember, the definition of multiply by 2 exists in the global memory. And copy array and multiply should be able to access it from global memory. So, but I can't remember whether we are just sending it the label or whether we're actually sending it the whole definition as well.
We're passing in the entire like definition. So when you get to this line right here, right, when we invoke it, we are passing in this particular array, right, which we did not save as a variable in global memory, but we do see multiply by 2. So it sees multiply by 2. And again, right, it looks at multiply by 2 and it's like, what is multiply by 2? Like, where can I find it? So then it finds multiply by 2 right here in global memory. And then it's like, oh, yes, it is this particular function definition, right? So then this gets popped into our instructions. So it gets paired with that.
So it doesn't just copy the address of the definition of the function in memory?
So it because right now you're talking about like being like passed by reference, right?
Yeah,
so
passed by value or passed by reference.
Yeah, so it is referencing exactly that same address and that same definition in global memory.
Yeah, so then that means copy array and manipulate does not have a local copy of the definition, right? Okay, so it is passed by reference. It is passing just the address.
Yes,
Okay.
there's not a copy.
Yes.
We don't make a copy of the definition. It points to the actual definition that has been stored. Yes.
Right. So that was my confusion, because when you say that, oh, we pass it the definition, to me, I take it as literally passing it the value of the, of the code. But that is not the case. We are just passing at the location of the address in the global memory.
Yeah. So just to clarify, right? I meant that kind of in the same way, right? So when I said like, oh, it looks for the definition, right? That's why we store the definition, and because it is a function, it's technically an object, right? Those are passed by reference, and so it does point to the exact same thing. So unless it was a variable, right? If it was my array right here, then it would make a copy. But because it is a function, you are exactly right. It points to the exact same, the actual function definition that was stored in memory. Does not make a copy.
Thanks.
Absolutely. Alina, did you have a question? I see your hand is raised.
No, I'm not sure if I just keep hitting like something accidentally on my keyboard that raises it.
Okay, no.
Sorry about that.
No worries. No, I think you might have to like take the hand down. Joseph is like loving all these. I'm loving all your emojis, Joseph. That's Hannah.
Hi, thanks. So I had a question about like methods, like such as push. Like, do they technically also like push onto the call stack?
That is a great question. Yes. All methods basically are just functions. So yes, those would also open their own local execution context. Those would also get pushed onto the call stack. We did just thank you for pointing that out, because I did mean to kind of like point that out, that push itself is a function, right? And so that would also open its local execution context. That would also get pushed in the call stack, but we only have a limited amount of time, you know what I mean? So but thank you for clarifying that, because yes, absolutely, it would. It is a function. It would. Anybody else? All right. Let us move forward, right? Let's wrap things up. It's time to wrap things up. So, how was this all possible? Like, how was it possible that we were able to do all these things? How is it possible that we can just like pass functions into functions? It's because, right, in JavaScript, Joseph, or did you want to answer?
Yes, Katrina, thank you. And I do apologize for not being able to open my camera. I'm working on several things. There was another person here as well. Please accept my apologies. I got called a little before this class and I've been on standby on a project. Just to jump onto your question, from what I understood, from what I gathered, was the fact that instructions is the appropriate parameter for us to use when we are passing a function into another function. This is what makes JavaScript a higher order function. Correct, Katrina? I'm sorry. A first-class citizen, a first-class language.
A first-class object.
There you go. First-class object language. Thank you. Thank you. So can you please help me understand, is this correct? The instructions parameter is something that is used in general.
It's just to generalize, right? So instructions in this case, right? Instructions in this case, it is just a parameter. So it is just a placeholder. It is something that you can name as you will. We only decided that instructions could be like the best way to name it in this case, because we are kind of passing in new instructions every time, depending on what we want to do with our array. And you are absolutely right? The reason it is possible is just functions are basically just objects. They're just first
Yes.
class objects.
Yes.
Thank you, Joseph. Absolutely.
So is it convention, Katrina? Last question. Is it convention?
To name it instructions?
Yes.
No, it is not. So instructions just made sense for because I was trying to make it clear, right, or remind you all that functions are a set of instructions. So maybe wait for a couple of slides and I will get back to you on something that you will probably see more often as a parameter for functions.
Thank you.
Absolutely. Thank you for your question, Joseph.
Thank you,
Okay,
ma'am.
so yeah, absolutely. So Joseph makes a good point here, right? Functions are just first class objects. They're just objects, just like any other object in JavaScript, which means that they can be stored in a variable. It can be stored as a property in an object, right? It can be passed as an argument to a function. It can even be returned from a function, right? It is just like any other JavaScript object, right? This is why it is possible with JavaScript. So I'm going to go back to Joseph's question a little later, but in this case, right, what do we think? Which is our I know that we haven't explicitly defined these yet, but in this example, can anybody guess what is our higher order function? Yes, Hannah.
The higher order function would be copy, array, and manipulate. And then the callback function would be multiplied by 2 because copy, array, and manipulate takes in a function as an input.
Yeah, absolutely. Yes, exactly. Great job. Yes. So exactly as Hannah said, right? Our higher order function is copy, array, and manipulate because it is the outer function that takes in our callback, right? Another function. Whatever takes in a function, that is the higher order function. And then the function that is being passed in, just as she clarified as well, is our callback. So given what Joseph was asking earlier, right? Oh, is it convention to call the parameter instruction? You will actually probably most often, again, it is not convention. We can name it whatever we want, whatever makes sense to you. But more often than not, right, you are going to see the parameter callback, right? Because you now understand it is a function that is going to be passed in. All right. So now that we've seen all this, right, it's not as complicated or as complex as you might think, right? Higher order function, it is what takes or returns another function. Callback function is the function that is being passed in. How do we feel about that? Oh, yes, Joseph.
Thank you. So is it safe to say, one question, is it safe to say that the callback function here is essentially multiplied by 2?
Exactly. So callback would be your parameter, right? This would be your parameter that you can name it whatever you want, right? Callback makes sense because it is a function that is being passed into another function, and multiply by 2 is the actual function that is being passed in, which is our callback. Does that clarify?
Yes, that clarifies. Absolutely. And thank you. Perfect.
Yeah. Okay. Awesome. So yeah, so higher order functions, again, takes in a function or passes out a function. It's just a term, right, to describe a specific kind of function. So any function that does that, we call that. So I know I mentioned map, reduce, filter, all these like built-in functions, right? And these are typically considered higher order functions because they take in a function. So I know we didn't really go into like, how do we use map? How do we use filter? But if we just quickly look at this example right here, where we actually implement map, right? Right here, we are actually passing in this like anonymous function, right? So into our map, which is a method in itself, right? A function in and of itself, we are also passing in another function. So that makes it a higher order function. Everybody get it? Everybody understand? Okay, awesome.
So whenever you're passing in map, reduce, or filter, that makes it higher order functions.
It makes it a higher order function because it accepts, it takes in another function.
Thank you.
Absolutely. Yes. All right. How do we all feel about higher order functions and callbacks? To be clarified what they are. Awesome. Yes, Erica, you have a question?
Yes, I was just going to say, can you repeat one more time with the example, which one is the higher order function and which one is the callback? I think I mixed it up and now I'm confused.
Is it with this example or this?
Yes.
Example?
Yeah, with the example we were using before.
This one, right?
Yes, yes.
So let me ask this question of you, right? You said you had a little confusion about which is which. What between copy array and manipulate and between multiply by 2, as far as we know, higher order functions, right, are a function that takes in a function. So out of these two, what is taking in another function?
Copy array.
Exactly. So that would be our higher order function. And then what is multiply by 2 then?
The callback.
And why is it the callback?
Because it's being passed in.
Exactly, because it is being passed in as an argument for instructions, right?
Awesome. Okay.
Yeah.
Thank
Awesome.
you. I appreciate it.
Of course. Any other questions? All right, let's wrap. I kept saying, let's wrap it up. And I'm still like, there are more slides coming. This is it, y'all. This is where we just review everything. So thank you so much.
No, don't go.
Thank you so much for hanging in there. Let's review. Listen, I still got a few more questions, right? I want to do a little quick round of review right here. So declarative readable code, right? We want to make higher order functions are great because it makes our code declarative, readable, makes it reusable because we want to keep our code dry. Feel free to just unmute yourself. This is the last part. We can just stay casual. What does dry mean?
Don't repeat
yourself.
Yes, love this group effort. Okay, don't repeat yourself, right? So what we need to do is we want to generalize our code so that we can reuse any logic that we write, and then we pass in different arguments every time we invoke our functions. All right, perfect. Now, what is the difference between a parameter and an argument? We just saw it with the last example when I explained to Erica, but anybody jump in. What is the difference?
So parameter is in the definition of the function, and an argument is what is passed to the function when it is invoked, and the parameter is then paired with the argument and gets assigned the value of the argument.
Perfect. Absolutely. Very well communicated. Yes, exactly. Parameter is just a placeholder in our function definition, right? And that argument is the actual value that kind of replaces that placeholder. All right, perfect. And they're paired. Perfect explanation. So Codesmith and Pro Interview Prep. One of the most popular topics, again, to test and interview, both for Codesmith and real life engineering jobs, are higher order functions. But before we move on to that, right, let's just have another quick review of the JavaScript principles. What goes through our code line by line, right? That weaves in and out of
thread of execution.
Thread of execution. Thank you so much, Marcellus. Next, where do we store variables and function definitions?
Either the global memory or the local memory.
Yes, memory. I heard global, I heard local. Absolutely, either way, it is our memory within our execution context. Perfect. And where do we keep track of the execution context that we are in? Of where our
call stack.
Call stack, exactly. Absolutely, you guys are doing a phenomenal job. Great. So now, right, the next step would be to explore our other workshops, other programs, right? From here, from what you learned today, right, this is especially callbacks, right? These are foundational Callbacks especially are super foundational for concepts such as asynchronous JavaScript. So we have another hard parts workshop on asynchronous JavaScript. So that would be something that you should think about going to if you haven't checked that out yet. Awesome. Bye. Thank you so much for joining tonight.